Hi everyone, today we will discuss permutations and combination. Now once we consider this permutation and combination, so it is nothing but a method to select certain objects out of suppose different number of objects. So now that selection, it can be done either on the basis of permutation or on the basis of combination. Now what is the difference between this permutation and combination? The orderly selection, it is termed as permutation, and at random selection it is termed as combination. So when we suppose there are n objects, let us say there are n number of objects, and out of that n number of objects we need to select R object. Now when we select this R object out of this n objects, either I can follow certain terms and condition, I can follow certain order, and then I can select this R out of this n. So in that case it will be termed as permutation. Now following without any restriction or any condition, this clear? So if it is just a case of at random selection, then that selection it will be termed as combination. So either we can use this combination method or we can use this permutation method. If there are no need of any orderly selection, then we can go for the combination. If there is a need of orderly selection, then we have to go with the permutation. Now you can see what is this orderly selection or at random selection. Suppose we have a classroom, and in a classroom certain number of students are supposed to sit, or they need to occupy the seats in the classroom. Now if we don't put any restriction that where the boys should sit, where the girls should sit, so it means they can occupy the seats available in the classroom in any manner depending on their choice, because we are not forming that the girls should sit in the front benches, the boys should sit after that. So there are no restrictions like that. So in that case boys can choose any seat, girls can choose any seat, and that will be a case of at random selection or at random arrangement. Now if we consider some order that the girls should sit in the first row or in the second row, then only the boys can sit. So it means there are certain restriction or there are certain conditions. Under that we can't have the at random arrangement or at random sitting of the students. So either it can, so in that case we are following certain rules that first the girls should sit, then the boys should sit. So these are the conditions which have been put as far as the arrangement of those students are concerned. So in that case we have to use this permutation. Now before we start with the elaboration of this combination and permutation, so there will be a term which will be coming across this topic, and that is termed as factorial. Now this factorial, we call it as, suppose if you have this n number of objects, we can say, or n number, then we can say this factorial. So factorial n, so what is the meaning of this factorial n? Either we represent like this or we represent like this. So this is factorial n or this is factorial n. What is the meaning of this factorial n? How it behaves? So in that case, so if you consider suppose this factorial n or factorial n, this is n into n minus 1 into n minus 2 into n minus 3 up to this one, and is starting from 1 to this value n. So n is an integer, it is a positive integer, we can't have the factorial of the negative integer. So n is positive integer, so n belongs to positive integer. Okay, so it will be n minus 1, n minus 2, all consecutive terms up to 1, starting from this number n, all consecutive number in the decreasing order up to this one. So that is the meaning of this factorial n. So if you consider this factorial 3, that means it is 3 into 2 into 1. If you consider suppose factorial 4, so it is 4 into 3 into 2 into 1 and so on. 4 into 3 into 2 into 1. Similarly factorial 5. So you will get 5 into 4 into 3 into 2 into 1 and so on. So that way we can see. define this. Now here we can have some other properties. Factorial n, it is n, n minus 1, n minus 2, n minus 3 up to 1. Now from this to this, can you say it is factorial n minus 1? If you exclude this term, then this becomes factorial n minus 1, because it is starting from n minus 1, so it is n minus 1, n minus 2, n minus 3 up to 1. So can we write this relation as n into factorial n minus 1? You can write this way, or you can write this way. N into factorial n minus 1 means factorial n, it is also equal to n factorial n minus 1. The same thing you can see here. Factorial 3, it is 3 to 1. Factorial 4, it is 4, 3 to 1. 3 into 2 into 1, is it same as this factorial 3? So this factorial 4 here, you can represent 4 into factorial 3. So 4 into this factorial 3. So this way also we can represent it. It means in general factorial n, it is equal to n into factorial n minus 1. This can also be represented as n minus 1 into factorial n minus 2, because after this it will be n minus 2, n minus 3, n minus 4 up to 1. So again that can be represented as factorial n minus 2. So depending on our requirement, we can break this entire sequence. So we can write factorial n as n factorial n minus 1. Here we can write n minus 1 factorial n minus 2, and so on. So that way you can arrange whenever you need these kind of situation, or you come across this situation. Now, so factorial 3, that is equal to how much? 3 into 2 into 1, that is 6. Factorial 4, it will be how much? 4 into 3 into 2, and 4 into 3, 12 into 2, that is 24. Similarly, factorial 5, 5 into 4, 20, 20 into 3, 60, 60 into 2, 120, and so on. So that way you can calculate the value. And factorial 1, it is equal to 1. Factorial 2, it is equal to 2 into 1, so it will be 2. Factorial 3, we are getting how much? 3 into 2 into 6, so it is 6, and so on. So that way we can calculate. But factorial 0, it has been assigned a special value that does not come or follow these property. That's why it has been assigned a particular value, or a special value you can say, such that factorial 0, it is equal to 1. So factorial 0 is 1, and factorial 1 is also 1. So this is a special value. It does not match with all these concepts. So it is a special value given to this factorial 0. So factorial 0, it is 1. Factorial 1, it is same as this 1. So these are the features of this factorial. Now let us come back to that definitions of permutation, combination, as well as their application. So here if we consider this permutation and combination, so now I hope you have understood the definition. This is an orderly arrangement. This is at random arrangement. So here you can see each of the groups of selections which can be made by taking some or all of a number. And that means if there are suppose n number of objects, so we can take r out of n, where r may be equal to n, r may not be equal to n, but that r is always less than or equal to n. So each of the groups of selection which can be made by taking some or all of the number n all at a time, or some number r out of that n things without reference to the order, without following any order, is called combination. Similarly, arrangement which can be made taking some or all of number of things is called permutation. So here we are getting this arrangement, and here, so each of the arrangement, here we are using the word arrangement, and here we are using the word selection. So selection generally it is used for at random, and arrangement it is used for orderly selection. If there are certain orders, if there are certain rules that we need to follow, so in that case we will consider this arrangement, and that is justifies this permutation. Here simply selection word is used at, so that means it is a case of at random selection, and we will use this combination. Now if we select R object out of n, if we arrange R object out of n, so that will be represented as NPR. R object out of n, arrangement of R object out of n, so it is NPR. P stands for permutation. Similarly, selection of R object out of n, so that we consider NCR. So NCR, C means again combination, so R object out of that n, selection of R object out of n, it is NCR. Arrangement of R object out of n, it is NPR. When we use the word arrangement, it is understood or it is taken that we are following certain rules or certain order. Here when we use this selection, it means we are just considering that there is at random selection, but it is not a hard fact that always when there is the word selection we have to go for NCR, if there is arrangement we have to go for NPR. It is not a hard fact that or clearly classified like this. It completely depends on situation, and on the basis of that situation you have to apply your mind whether I should use the concept of combination or I should use the concept of arrangement. But the basic difference remain is whenever we do some kind of selection, whether it is following this some order or not, it means we have to check whether it is a case of at random selection or it is a case of orderly selection. So that we have to consider, and once we consider that, then the picture will be clear that whether we should go with this NCR or whether we go with this NPR. Now there is fundamental theorem. This fundamental theorem says if a certain things can be done in M ways and M ways, and when it has been done, when it has already been done one in any of the ways, a second thing can be done in N ways. Suppose a certain thing is done in M ways, and when it has been done, other thing it can be done in N ways, then the total number of ways in which two things can be done is M into N. It is the product of those, it is not the addition M plus N. Certain things can be done in M ways, remaining it is done in N ways, which means the total it is M into N, not M plus N. That we have to take care. So that's why here certain things can be done in M ways, and when it has been done, the second thing can be done in N ways, then the total number of ways it becomes M into N. Just for example, we can understand. Suppose students are supposed to sit in the class. Now let us say first girls will occupy the seat. So girls have occupied the seat, suppose in M ways. Let us say girls have occupied the seat in the class in M ways, and then the boys have occupied the seats in the same class in N ways. Okay, in N ways. Then the total number of ways in which the boys and girls have occupied the seat, it will not be M plus N, but it will be M into this N. So that means, and that this principle or this concept, it is termed as fundamental theorem, because here it is the product of these two number of ways, it is not the addition of the two number of ways. One event has occurred in M ways, another event when first has already occurred in M way is occurring in N ways, then the total number of ways of occurrence of both the event, it will be M into N, not M plus N. Now here, so NPR denotes the number of permutations of n different things taken R at a time, which is equal to NPR, that is n minus 1, n minus 2 up to n minus R plus 1. So NPR, this is the expansion here, n minus 1, n minus 2 up to n minus R plus 1 up to the last term. Last term here, that becomes what? The R term, because we are taking R terms out of n terms. So NPR n minus 1, n minus 2 dot n minus R plus 1. Now, and this is termed as factorial n upon factorial n minus R. Factorial n upon factorial n minus R. That you can write NPR is equal to factorial n upon factorial n minus R, which is equal to your n minus 1, n minus 2 dot n minus R plus 1. This is n minus r minus 1. It is n minus r minus 1. So that finally becomes n minus r plus 1. That you can see here. N minus r plus 1. Here, this n minus r plus 1. So it is this can be represented as n minus r minus 1. So finally, if you replace this bracket, so it becomes n minus r plus 1. Mean r minus 1 what? Up to r objects are selected out of n object. So here this goes up to what? R minus 1th term. If 4 objects are selected out of suppose 10 objects, so here it will be up to what? 4 minus 1, that becomes 3. So n minus this 3. So that is the meaning of this. Okay. Similarly, this NCR means NCR, that is NPR upon factorial R. The meaning of NCR is factorial n upon factorial R factorial n minus R. Here you can see NPR is just factorial n upon factorial n minus R. But in NCR it is factorial n upon this factorial R into factorial n minus R. So now we can correlate this NPR as well as NCR. So can you write NCR? It is equal to NPR. This is NPR. This is your NPR. This factorial R is the extra term. So we can replace NPR divided by this factorial R. So NCR is NPR upon factorial R, or vice versa. NPR is factorial R into NCR. It means this way we can correlate this NCR as well as NPR. It means any problem can be solved using the concept of NPR, permutation or combination. This gives us the clue that any problem can be solved using the concept of combination and permutation, but the only thing that you have to justify or that you have to check is whether it is a case of at random selection or whether it is a case of orderly selection. If we can distinguish these two, then taking care of each and every condition there, we can move either using the concept of combination or using the concept of permutation, and finally we can use this relation to combine both the concept. So NPR, again I will just repeat, factorial n upon factorial n minus r. NCR is factorial NPR upon factorial r. Why factorial r is there, that you can see, because elaboration of NCR is factorial n upon factorial r factorial n minus r. R lies between what? 0 to n. Means it is less than or n, or it is equal to n. They are all positive integers. That's why the limit is within 0 to this n. Now the number of permutations of n things taken all at a time when p of them are similar. Suppose out of n number of things, there are certain group which are similar. P number of things are similar. Okay, P of them are similar of one type, Q of them are similar of another type, R of them are similar and third type, and remaining n minus P plus Q plus R, they are all different. Means we can just understood. There are suppose fruits. Some are mangoes out of that, some are bananas, some are apple, and so on. If we consider mango as one group, banana as another group, apple as third group, means total number of fruits, there are suppose n. Out of this n type, P of them are similar and one of type. Mango are in how many numbers? P numbers, and they are supposed to be similar because they are considered as mango. So mango in number it is P, and they are of one type, means mango type. Similarly, Q of them are similar and of another type. So there are Q number of bananas, and they are again treated as similar bananas. Similarly, suppose R of them are similar of third type. Let us say they are all apple. So remaining are all different. So remaining will be what? Total number n minus P plus Q plus this R and so on. So remaining they are all different. Then the number of permutation of all n things taken all at a time. Yani we are arranging all those objects n where this condition are there, P of one type, Q of another type, R of another, and remaining all are different. So that can be simply done as factorial n upon factorial P, factorial Q, factorial R. Remaining all different means factorial 1, factorial 1, factorial 1, and factorial 1, that is 1. So we need not write here. So it is factorial n upon factorial P, factorial Q, factorial R. It means, again to summarize, there are suppose n number of objects. Out of those n number of objects, P are of the same type, Q are of the another type, and R of the another. Then they can be arranged among themselves, taking all at a time in factorial n upon factorial Q, P, factorial Q, factorial R ways. Next you can see some of the relation. NC1 plus NC2 plus NC3 plus NC dot NCn, it is equal to 2 to the power n minus 1. 2 to the power n minus 1, because NC naught plus NC1 plus NC2 dot NCn, it is equal to 2 to the power n. It starts with NC naught, when 0 selection out of n. But here we are, NC1 means one object is selected out of n, two objects selected out of n, all n objects selected out of n. So if you include this 0 here, then this is equal to 2 to the power n. But 0 object out of n, it does not make any sense. So we have to remove this. It means from here, NC1 plus NC2 dot NCn, that becomes what? 2 to the power n minus this. NC naught, it is equal to 1. If you calculate the value of NC naught, that using these relation, it is equal to 1. So bring it this side, so it becomes 2 to the power n minus 1. So that's what we have here. NC1 plus NC2 plus NC3 dot NCn, that is equal to 2 to the power n minus 1. Similarly, now these concepts are used when there is concept of at least selection. Let us say you have this n number of objects, and out of that we need to select at least one object. So when we have to select at least one object, what does this mean? Either I am free to take only one object, or I can select two objects, or I can select three objects, or I can select all the n number of objects. If I select one object, it means it is NC1. If I select two objects, NC2, NC3, and so on. So that gives you what? Selection of at least one object, means I am free to select either one or all. So either one or all. So that becomes NC1 plus NC2 plus NC3 dot NCn, and that becomes your 2 to the power n minus 1. Similarly, NPR, again these are the various transformation, you can say, of the relations, that factorial n upon factorial n minus r. So you can also write it as 1 plus 1 into 1p1 plus 2 into 2p2 plus 3 into 3p3, and so on. These things need not be kept in your mind. Wherever necessary, you can always derive and you can always use it. Similarly, NCR, it is also equal to NCn minus r. NCR is equal to NC n minus r, means from the beginning or from the end it will be same. So NCR, it is equal to NC n minus r. NC naught is equal to NCn. This is the first term and this is the last term. So NC naught is equal to NCn, and that is equal to 1. That's what we have just discussed. NC naught is equal to NCn is equal to 1. NC1, it is equal to 1. These things you can calculate using this relation. But if you can keep it in mind, calculation becomes fast. So NC1 is equal to 1, NC naught is same as NCn, NCR is same as NCn minus r. So if you keep this only in your mind, then you can put NC naught is equal to NCn. So substitute here NC naught, r is replaced by 0. Here again r is replaced by 0. So NC naught will be equal to how much? NCn. So we have. So simply keep it. Rest of the things you can always manipulate. Factorial r into NPR, factorial r into NPR, okay, that will be equal to how much? Factorial n minus r, np n minus r, np naught is equal to 1, np1 is equal to n, npn minus 1 is equal to npn, that is equal to factorial n. All these relations are based only on this. Factorial npr is equal to factorial n upon factorial n minus r. These are just the elaboration of this relation in different ways, so that in simplifying problem we can use whenever necessary. Now other properties are, if ncx is equal to ncy, then either x is equal to y, either x is equal to y, or x plus y is equal to n. X is equal to either y or x plus y is equal to this n. Now again using the relation NCR plus NCR minus 1, that is equal to n plus 1 CR. These are important relation and you should keep in mind. Always we will be using this, so always we need not calculate it. We can directly use NCX equal to NCY, so x equal to either y or x plus y is equal to n. NCR plus NCR minus 1. NCR, here one term is less than this, so NCR minus 1, that becomes n plus 1 CR. Whenever we have the addition of this sequence, we can always make use of this relation to minimize the number of terms. So NCR plus NCR minus 1, n plus 1 CR. Obviously R lies between 1 and n. NPR, n minus 1 PR plus n minus 1 CR minus 1. Here it is a combination of both. Here you have this permutation, here you have this combination term. So these kind of terms can also be manipulated. But this is rarely used. These two are commonly used and this makes your calculation simpler. These two. NCX, NCY, x equal to y or x plus y is equal to n. NCR plus NCR minus 1, it is n plus 1 CR. Let us see some of the more feature. The number of combinations of R things, obviously R will be less than equal to n. Out of n identical thing is what? 1. If you have to arrange n identical thing, in how many ways can we arrange identical things? Only one, because whatever you do the combination, all will look similar. So it means there will be only one way of arranging n identical things. So the number of combinations of R things out of n identical thing is 1. The total number of selections of 0 or more things from P identical thing is P plus 1. The total number of selections of 0 or more things, including 0 as well as more things, from P identical thing is P plus 1. The total number of selections of some or all out of P plus Q plus R things, where P are alike and of one kind, Q are alike of second kind, and R alike of third kind, is P plus Q, P plus 1, Q plus 1, R plus 1 minus this 1. That we can understand. Here just now we have considered in this. You can see this relation. Okay, here also we were considering of one type. Objects may be like it is mangoes, bananas, apple and so on. So they are not all identical, they are all different. Is this clear? But they are of different types. So we were having this relation. But in this case, here you are getting what? All identical. The total number of selections of some or all out of P plus Q plus R thing, where P are alike, they are identical of one kind, Q are alike of second kind, R are alike of third kind, and that becomes P plus 1 into Q plus 1 into R plus 1, this minus of 1. Again, out of P plus Q plus R things, P be alike, Q be alike, and another kind, and the rest are all different. Then the total number of combination, again it is P plus Q, P plus 1 into Q plus 1 into 2R minus this 1. So just try to keep these things in your mind, that these are important concepts, and in case of some complicated situation, if we can use this, the problem becomes simpler. The solution part of that becomes simpler. The number of combinations of n things taken are at a time. n things taken r at a time, when each may occur once, only once, each may occur once, twice, thrice, etc. up to r times in any combination is n plus r minus 1 cr. We will see some examples, so these things will be more clear. The number of combination of n things taken r at a time, when each may occur once, twice, thrice, etc. up to r times in any combination is n plus r minus 1 cr. The number of ways in which we can divide p plus q plus r plus s dot dot unlike things. Up to here it was the like or of one type. Here it is all unlike into unequal parts containing p, q, r as things respectively, and that becomes your factorial of p plus q plus r, means all, divided by factorial p, factorial q, factorial r, factorial s, and so on, because all are unlike. The number of ways of dividing mp things, m into p, the total number of things it is m into p, into m identical groups of p things each. M identical groups, and each group is containing what? Group of p things. In each group there are p number of things. Total number of objects it is m into n. We are categorizing them into m identical group, and each group contain p things, and that becomes factorial mp upon factorial m factorial p to the power m, because each group contain p. So p into p into p, and factorial p, factorial p, factorial p, that makes it factorial p to the power m. So m factorial mp upon factorial m factorial p to the power m. Number of ways of dividing mp things into m different unidentical group of p things. Here it was what? Identical group. Here it is unidentical group, and that becomes factorial mp upon factorial p to the power m. You can see this difference. Here it is factorial p to the power. Factorial m is not appearing here because m things into m different, but unidentical group of, here it was identical group of p things. So that is the basic difference there. If n is even, then the greatest value of NCR is NCM, where m is equal to n by 2. Okay, any half of this. And if n is odd, then the greatest value of NCR is NCM, where m is equal to n minus 1 upon 2 or n plus 1 upon 2. So these are the concept that we simply get from simple algebra, that if m is equally divided, if n is even, in that case the greatest number it will be NCM, where m is equal to n by 2. But if n is odd, in that case this r will be such that m is equal to either n minus 1 by 2 or n plus 1 by 2. The number of combinations of n distinct objects taken r at a time. Number of combinations of n distinct objects, taken r at a time, when k particular objects always occur is n minus k c r minus k. If k particular objects never occur, then the number of combination of n distinct objects taken r at a time is n minus k c r. It is n minus k c r. Here it is n minus k c r minus k. Another property, these are the some of the features you may keep in mind, you may not be able to keep in mind, but when we start solving problems, all different type of questions will appear, and from there it will give you a clear picture how to use all these things and where to use all these concepts. If there are k objects of one kind, l objects of another kind, then the number of ways of choosing r objects out of these objects, it is l plus k dot dot, means all the objects given by the coefficient of x to the power r in the expansion of 1 plus x square x cube x to the power k into again 1 plus x up to x to the power l. And if further one object of each kind is always included in such a collection, then the number of ways of choosing r objects is given by coefficient of x to the power r in the product x plus x square, x cube, x power r into again x square, x plus x to the power n and so on. Now again these things can be get. I understand that each and everything you are not getting this properly, because these things will be there into your mind only when we start solving problems based on all these concepts. We can also keep this relation in your mind: a naught plus a1x plus a2x square dot dot into b naught plus b1x b2x square dot dot is equal to c naught plus c1x c2x square and so on. CR it is equal to a naught br, a1 br minus 1 means coefficient of this r here, or that term you can say in general form: a naught br plus a1 br minus 1 dot dot ar b naught. Coefficient of x to the power n in 1 minus x to the power n, it is n plus 1 up to n plus r minus 1 divided by factorial r, which is equal to n plus r factorial of n plus r minus 1 divided by factorial r factorial n minus 1. So these are some of the properties. They are based on the binomial expansion. So when we start simplifying problems, it will be more clear, and in your binomial expansion, using that we will be able to elaborate more and more. Thank you.